We are on page 4 of the Exponential Functions Review worksheet. We're looking at transformations of graphs, and if you go back to, I think it was the second video, I talked a little bit about these graphs. Let's kind of take a look real quick. Find out where that graph is really quick. Sorry. Aha, there it is. Sorry about that. In number 4 and 5, we graphed these, the 3 and the 1/3. So this was a transformation we talked about. We're like, hey, this is a reflection over the x-axis, or the y-axis, excuse me. So when you see a number and it's reciprocal. There are obviously other transformations we're going to do, but let's just keep that one in mind. And before we get too far on number 10, we can just see that 11 was basically number 4 and 5. So just to kind of re-emphasize that point, when we have something like this, this is a reflection over the y-axis. Okay. Also, we learned in those, number 4 and 5, that if I wanted to write, 3 to the negative x, that would give me a reflection over the y-axis, but that's the same thing as writing 1 over 3 to the x. So in this one right here, this is also a reflection over the y-axis. Okay, so notice that if I have 2 to the negative x, I can rewrite that as 1 over 2 to the positive x, which is the same thing as 1 over 2 to the x power. And then we'd say, oh, yeah, those are reflections over the y-axis. So no matter what function you have, if you make the x negative before you do whatever operation you're doing, you are going to end up with a reflection over the y-axis. For example, we saw a while ago something that looked like this, x squared, right? If we make the x negative before we square it, that's going to be a reflection over the y-axis. Another one we had was like absolute value of x. If we make this negative before we take the absolute value, that's going to be a reflection over the y-axis. We had the square root, right? If we make the x negative before we take the square root, that's going to be a reflection over the y-axis. So whenever you make x negative, and that's the first thing that happens before you can complete the function or before you can do the operation, it's going to be reflecting over the y-axis. So in this case, before you do 2 to the power, whatever x you put in, you flip it, and then you take 2 to that power. That's going to be a reflection over the y-axis. Okay, now this time, number 12, the negative's on the outside. So if the negative's on the outside, that happens kind of at the end, right? It's like 4 to the x, and then whatever, make it negative at the very, very end. This is going to be a reflection over the x-axis. Right. When things happen on the inside, they affect the graph horizontally, or left to right. And to do a horizontal reflection, it's going to have to go over the y-axis. When you put things on the outside, then it's going to affect the graph vertically. So in this case, it's going to reflect it over the x-axis because a vertical reflection goes this way. Just to compare it to other things that we've seen before, if I had x squared, how would I make that flip over the x-axis? I put the negative out in front. If I had absolute value, sorry, this is not equal, this is just a transformation. If I had the absolute value of x, how would I flip that over the x-axis? I would do negative absolute value of x with the negative on the outside this time. If I want to take the square root of x and reflect it over the x-axis, I'd put the negative on the outside, just like that. So we're kind of building on ideas that we had before. We already talked about all these different kinds of transformations and how we do them on different functions. We're just applying those transformations to exponential functions. Okay, let's take a look at this one. So this here, this -3, notice that it's in the exponent. So if we want to do horizontal shifts, we put a number inside with x before an operation happens. So for an x squared, if we wanted to transform this one, we do like a x minus 3 squared. If we had an absolute value of x, we could do something like absolute value of x minus 3 squared. If we had a square root of x, we could do something like the square root of x minus 3. Those all subtract 3 from the x value before, sorry, this shouldn't be a squared here, before we do the operation. Whether it's a square or an absolute value or a square root, this happens to the x before that. And the same thing is here, right? We subtract 3 from x before we take 5 to that power. So whenever you have some number kind of on the inside with x before an operation is happening, that's going to be a horizontal shift, and it's going to be kind of the opposite of what we expect here. This negative 3 looks like it's going to go left, but these all go right. So all of these are transformations of right 3 units, and this is the same thing. So g of x is this graph, 5 to the x, shifted to the right 3 units. So translation or shift, 3 units right. Okay. Now in this next one, we have, there's a couple things going on, but let's take a look at the minus 3 first. So this minus 3 is not on the, it's not in the exponent, right? You see that? This one's in the exponent, this is not. So this is happening at the very end of the equation, after everything is all done. This is the last thing that happens, which means this is going to be a down 3. This is going to be a vertical translation. The other thing we have going on is we have kind of this situation, right? 2 to the x going from 1/2 to the x, right? Or 1/2 to the x going from 2 to the x. So this right here, this piece, just because this is a 1/2 and this is a 2, that's going to be a reflection over the y-axis again. Okay, but after that, we're also translating. So there's actually 2 transformations going here in here. Translation down 3. So there's a couple things going on there. All right, and over here we also have 2 transformations going on. We start with this guy, and how is this different? Well, we're multiplying it by 5. That's going to be a vertical stretch. Right, when we have a number out here, that also, if you recall, that changes that's like our initial value, kind of. We have this +4, which is kind of change things a little bit, but this multiplier, it's kind of like an initial value. So this is a vertical stretch by a factor of 5. And then it's going to be also it's going to move up. So this is not in the exponent. If that +4 was in the exponent, we'd say that's a left 4. But since it's out here outside of the exponent, this is going to be an up 4. So we'll say translation 4 units up. Okay. So those are some transformations. I think I covered all of the ones that you're going to need to know. You're going to have to know how to do a left-right shift. You're going to have to know how to do an up or down shift. You're going to have to know how to do a horizontal or reflection over the y-axis. You're going to have to know how to do a vertical reflection or a reflection over the x-axis. And you're also going to need to know about that vertical stretch factor. So that pretty much covers all of them. You can, practice if you want to give yourself some extra ones or whatever. You can kind of, play around with it and see what you would get. For example, you could say, okay, I want to take 3 to the x and I want to move it to the right 4. And I want to move it up 2. Right? So you can do something like, you can kind of do stuff like that. Or just practice. Or you say, I want to move it to the left 4, and then I want to flip it over the x-axis. You can do stuff like that. So, okay, let's take a look at the last 6, which are compound interest problems. So there's actually 2 formulas that you're going to need to know here. One is if you're compounding like a specific number of times per year. So when you see words like annually, monthly, quarterly, those are all a set number of times per year, right? Annually is once a year, monthly is 12 times a year, quarterly is 4 times a year. If you have a number of times that you're compounding per year, you're going to use this formula. I'll write it over here. The amount of your investment after some time in years is equal to the principal, right, the starting amount, times 1 plus the rate as a decimal over the number of compounds per year to the number of compounds per year times the number of years. I got a little smooshed. Let me rewrite that. All right, I'll write it here because we need to use this for this first 3. So A of t amount in terms of time. Time is in years, by the way. Equals P for principal, starting amount of the investment, or it also could be for a loan, plus R, the rate as a decimal, divided by N, the number of times you compound per year, to the N, the number of times you compound per year, times T. Okay, we're going to use that for these 3. So all we got to do is we got to pull the pieces out, we got to throw them in the formula, and then we're going to use a calculator to help us out with this. So let's look at the numbers. Final amount. Okay, so we want the final amount. We're investing $2,500. So that's the amount of money we're investing here. So principal, $2,500. 1 is 1. That doesn't change. That just represents 100% of what we started with. Okay, the rate as a decimal. This is where it can get a little bit tricky. If we're in a percent and we want to change it to a decimal, even though this already has a decimal point, we take the decimal point and we move it 2 to the left. So 1, 2, and if we have an extra space, we got to fill it with a 0. So this is 0.025. That's your rate as a decimal. Divided by the number of compounds per year. Since it's annually, it's 1 time per year. To the power of 1, right? Because that's we're compounding 1 time per year for 30 years. Okay, so this is what you need. Now there's ways to type this in your calculator so that you can just type it all in one shot, but you have to be careful with order of operations and the calculator, trying to figure out what you're talking about. The calculator is going to default to order of operations, so if you don't know, how to type it in, you're going to get the wrong thing. So that's probably what I would practice with here. I'm going to give you the answer real quick in just a second once I find it. And then you guys can just check on your calculator to make sure that you know how to do that correctly. And this is, of course, the amount after 30 years. Okay, so when you punch that all in, you're going to get $5,243.92. And since we're talking money here, we'll just round to the nearest hundredth because that would be cents. Okay. 17, again, the instructions for these are all the same. We're looking for a final amount of an investment, right? So we're going to assume that this is the initial amount that we're investing. We're investing $1,000 at 6% interest compounded monthly. Okay, so the amount after 20 years, and this is just function notation. We're not doing anything with this. This is not A times 20. This is just the amount after 20 years, just a label here. You don't even maybe need to write this part if that's confusing for you. But we have the initial amount, the initial value is 1,000, times 1, that 1 is always there, plus the rate as a decimal, so 6%, right? The decimal would be here then, 1, 2, so 0.06, over the amount of times compounded per year. So this monthly, right, tells us it's compounded 12 times per year. 12 times per year times 20 years, right? So if you're typing this into a calculator, you may want to put parentheses around these because it may not know that the 20 is in the exponent. The way I'm writing it, it's obvious, but for a calculator, it may not know. And you can do this a piece at a time as well if you want to be safe. So like if it was me, I'd probably do something like this. 0.06 divided by 12. That gives you 0.005. Add that to 1. Okay, now you got 1.005. Okay, now take it to this power, which would be 240. So 1.005 to the 240. Figure out what that is. Then take that number and multiply it by 1,000. So you can do it step by step, and that way you don't have to worry so much about order of operations. You just do the operations in the order that you know it's supposed to happen instead of trying to get your calculator to figure out what you want it to do. But when you do that, and you do it correctly, you get $3,310.20. Okay. All right. Now, as we go through this, I'm hoping that you guys are trying this on your own. I'm giving all these videos here because if you get stuck, I want to make sure that you have plenty of resources up front. You don't have to wait for me to get back to you. However, since we're kind of studying for a test, I would recommend that you don't just go here and write down all the answers. What I would do is I would see if you could do it on your own first, and then check back if you get stuck or whatever. So don't sit there and go through this whole thing without trying it. I would, on this next one, for example, I would say, 18, try it on your own. If you watch me do 16, try 17 and 18, make sure you're good. I'll show you 19, and you can do 20 and 21. So use this as a resource and not as a crutch, because you're not going to have this on your test. So use it to help you as a study aid and not just as a way to get your homework done. Because we'll find out, right? We'll find out next week when you take your test whether you really understood what was happening and you practiced, or whether you just kind of like followed, wrote down the same thing I wrote down. Okay, 18. So $2,000 is the initial amount we're investing here, right? So times 1 plus 8% as a decimal. So that'd be 0.08 over 4. Quarterly is 4 times per year, right? Like quarters in a dollar. 4 quarters in a dollar. We're compounding 4 times a year times 10 years, so that's going to be 40 when all is said and done. All right, so this is going to come out to be 0.2. So it's going to be 1 plus 0.2, or 1.02, to the 40th power, 1.0 to the 40th, and then times that by whatever that is, by 2,000 is going to get you your final amount here, which in this case is $4,416.08. All right, in these last three, we change up the formula we're using a little bit, because notice that these are compounded continuously. That's our key word. So we don't have a specific number of times. It's like always compounding. It's infinite number of compounds per year. There's no interval where it's compounding. So that's a key word to tell us we got to switch formulas. We can't use a formula that has n in it, because n is number of times per year, and again, continuously is infinite many times per year. So we need a different formula. And the formula we're going to use is the amount of your investment or loan after t years is the principal, p, times e to the rt. Now remember that e is just a saved number in your calculator. It's like pi. It's an irrational number. Pi is like 3.14159. E is like 2.71 something. So it's in your calculator. You're going to need to know how to find that e on your calculator, but it's a number there. And this is actually an easier formula to work with. So p is the principal, e is that irrational number that's approximately 2.71, but use the stored value in your calculator. R is the rate as a decimal, and t is still time in years. So the only thing that's different, the p is the same, the r is the same, the t is the same. The r is in a little bit different of a place, but the e is kind of the new symbol here, and that's for that number. So if we're investing $65,000, that is the principal, and we're investing it at a rate of 2.5%. So we have the e here. 2.5 as a decimal, move this over, is 0.025. And we got to multiply that by 5 years. Okay? So if it was me, and I was doing this one step at a time in the calculator, I would say I need to do 0.025 times 5 first to figure out what I get there. And then I take that thing, and I take e to that power, whatever that number was, e to that power. And then that's going to come out kind of gross. I'm going to multiply that number by 65,000, and that will give me how much money I have at the end of these 5 years. So that is going to give you $73,654.65. So again, you need to practice with your calculator. Make sure you find that E button. You'll be able to use a scientific calculator on your home or on your test. So make sure that you have one of those handy. You can't use a graphing calculator though, because there's going to be some graphs on the test, and you need to be able to do those by hand. So make sure you have a scientific calculator that you can use on the test. All right, these next two are just kind of the same idea, right? So amount equals P times e to the RT. So $10,000 times e to the rate as a decimal, so 5% would be 0.05 times 20 okay, which is going to come out to be 27,182.82. All right, and then the last guy, PE to the RT. So 250,000 times E. Now this rate is going to be tricky. This is 0.5%. So we need to move the decimal place over 1, 2, which is going to give us 0.005 times 15. Okay, and that is going to come out to be $269,471.04. Okay, so that's how we do those. Now on your review, or your test review, your practice test, I might have a problem a different way where I give you the final amount and you have to find the initial amount. And I'm going to give you a practice test, so we can talk about that at that time. But you just have to kind of be able to tell if the dollar amount that you're getting is the P or the A. Is it the investment amount or the initial amount, or is it the final amount? Okay, so in this worksheet, they're all asking you to find a final amount, which means they have to be giving you the initial amount, which kind of makes sense. But it doesn't always have to be that way. And what we did, when we practiced before a few weeks ago, we had a few problems that were the other way. So we'll kind of tackle that in the next assignment in our test review. But the test is going to cover all of this stuff, exponential functions, plus your conics, your circles and your parabolas, which includes the 4 forms of parabolas and knowing how to complete the square and convert between them and things like that. So that's coming up next. We'll review for the test by taking a practice test, and then we'll have a online Google Forms test early next week. Thanks for tuning in. Hope this was helpful. Remember, office hours are 10 a.m. to 12 p.m. Monday through Friday. That's when I'm checking my email the most. I will try to get back to you if you're emailing me at other times, but that's kind of when I'm sitting with my email open waiting for you. So let me know if you need some help, and have a great day, guys.